And for our last lesson, we're going to learn a different method of solving quadratic equations, how to solve by factoring. First, the zero product property tells us that for any real numbers a and b, if a times b equals 0, what does that tell us about a and b? If I'm multiplying two numbers and I get 0, then that means that a has to be 0 or b has to be 0. One of the two numbers must be 0, because the only way to multiply two numbers and get 0 is if one of them is 0. And using that, we can solve by factoring. This is how we do it. First, you want to solve the equation for y and then set the equation equal to 0. So make sure it's solved for y and then substitute in a 0 for y. Then you're going to factor it. Remember, of course, to factor out the GCF first and follow all the factoring rules we learned last unit. Once it's factored, you're going to set each factor equal to 0 and then solve it for x. Let's see how that looks. So our first step was to solve it for y and then set it equal to 0. This equation is already solved for y. I have the y by itself, so I'm just going to go ahead and replace that y with a 0 and then copy down the rest of the equation. Step 2 is to factor it, but conveniently they've already factored this one for us. So I can go to the next step, which is to set each factor equal to 0 and solve for x. So remember that zero product property tells me if I multiply things together and get 0, one of them has to be 0. So what's happening here is that I have 2 times x minus 2 times 2x plus 3 equals 0. In order for this to be true, one of those factors has to equal 0. Because again, the only way to multiply and get 0 is if you're multiplying by 0. So I'm going to set each factor equal to 0. So the GCF does count. And then I have x minus 2 equals 0 and 2x plus 3 equals 0. Now that first one, 2 equals 0, you probably wrote that down and said that doesn't make sense. And you're right. In this case, 2 can't equal 0. So that's not going to give me a solution. If your GCF has a variable in it though, it will give you a solution. So that's why it's a good idea to mark it down just to say, does this give me a solution? No? Okay, moving on. Over here, I would add 2 to both sides and get x equals 2. That's one solution. Over here to solve for x, I would first subtract 3 on both sides to get 2x equals negative 3. Then I would divide both sides by 2 to get negative 3/2. So my solutions are negative 3/2 and 2. Next one. It's already solved for y, so I'm going to replace that y with a 0. And then we're going to factor. First thing I do when I factor is look for a GCF. Does this have a GCF? Yes, they both have an x. So I can factor out an x, and that leaves me with x minus 3. Well, I can't do anything else with x minus 3. There's no more GCF, and it's only a binomial. The only thing you can do with a binomial is if it happens to be a difference of squares, which neither of those are perfect squares, so we are done. So once you factored it, set your factors equal to 0. So this one, x equals 0, well, that one's already done. That one's the solution. And over here, x minus 3 equals 0. So add 3 on both sides, and x is 3. So your solutions are 0 and 3. Solve for y and then set the equation equal to 0. This one happens to use function notation, but remember that function notation, in this case g of x, is the same as y equals, so it's still solved, and I can replace that with a 0. Now I'm going to factor it. I look for a GCF. Do I have a GCF? Not this time. So this is a trinomial with an x squared in the front, so I know that I need x's in the front, and I need to find two numbers that would multiply to 4 and add to negative 5. So I know that's going to be two negative numbers, specifically negative 1 and negative 4. set your factors equal to 0. And solve them. Add 1 on both sides here. So I have x equals 1. And then over here, I have x equals 4. And I will also take this time to remind you that we can also write our answers or solutions in our curly brackets. So you may see it written as 1, 4 instead. Next one, another function notation question. Well, again, f of x is the same thing as a y, so I will replace that with a 0, and then I will factor this. I check for a GCF. There is none. This time I have a number in the front, so I will have to guess and check. So what multiplies to 6x? Well, it's going to be either a 6x times an x or 3x and 2x. But 1 is just 1 times 1. So I know the back's going to have to be a 1 and a 1. It is negative 1, so I know I need a plus and a minus. I don't know which one I want to go where. But let's try out the 3 and the 2 and see how that goes. So if I put in 3x and 2x, my middle terms would be 3x and 2x. If I make one of those negative, can I get negative 1x? Sure. I'd want it to be more negative, so I want this to be negative and this to be positive. So that'll be negative and that'll be positive. And that means I have factored it fully, so I will get rid of this so I can finish the problem. Once it's factored, set all of your factors equal to 0. Over here, I will subtract 1 and then divide by 3 to get x is negative 1/3. On this side, I would add 1, get 2x is 1, divide both sides by 2, and x is 1/2. So my solutions are negative 1/3 and 1/2. This time I do not have y solved for. I have y minus 81 equals 9x squared. So I would first have to get that y by itself by moving the 81 to the other side by adding it. And make sure that if you have to move anything, you're writing the other side, your quadratic equation, in standard form so that it's easier to factor. So that means my 9x squared goes in the front and then plus 81. Let's factor. Oh, also, let's go ahead and make that y a 0 as well. But let's factor this. I look for a GCF and I notice that they both have a 9 in common. And that gives me x squared plus 9. And then I see if I can factor this. So a binomial, again, I can only factor it if it's a GCF, which I already did, or a difference of squares. And while these are both perfect squares, there's a plus and not a minus. So it can't be a difference of squares if it's not a difference. So I can't factor this any further. And then I can try to set my factors equal to 0 to find solutions. So this one, 9 equals 0. Well, that's not going to give me anything because 9 will not equal 0. If I do this one, x squared plus 9 equals 0. I can move the 9 to the other side by subtracting it. I get x squared equals negative 9, which brings me back to what we did last lesson. I can get x by itself by taking the square root of both sides, but then I'm taking the square root of a negative, which I cannot do, which means there's no solution here and there's no solution here, so this problem has no real solution. Last one, I've got to get my y by itself, so I want to move that 24x to the other side. And again, be careful that you are writing it in standard form. I'm also going to go ahead and change that y to a 0. X squared term goes first, then my x term, then my constant. Let's factor it. First, I look for a GCF, and I see that they are all even numbers, so I can take out a GCF of 2, which leaves me with 4x squared plus 12x plus 9. And there's no other GCF there, so we're going to keep factoring. Keep the 2. I do have a number in the front, so I have to think about what multiplies to the first and last terms. So 4x squared could be either 4x times x or 2x and 2x, and 9 could be 1 and 9 or 3 and 3. So I'm going to start with 2x and 2x and 3 and 3 and see if that works. Because it multiplies to a positive and adds to a positive, I know they would both have to be positive. Let's check that middle term. 2x times 3 is 6x, 3 times 2x is 6x, and 6x plus 6x is 12x. So this is in fact correct. And I notice that it's the same binomial twice, so I can even rewrite this as, keep the 2, 2x plus 3 squared. So when I go to check my solutions by setting them equal to 0, again, I can say, when does 2 equal 0? It doesn't, so let's skip that. This one, it is the same binomial twice, so I don't have to check what the solution is twice. I just need to know, when does 2x plus 3 equal 0? Subtract 3 on both sides. 2x equals -3. Divide by 2. And the only solution to this one is -3/2.